Hello everyone, welcome to MechDraft and Strength. Today we are starting a new topic, that is sectional orthographic projection. So we are started with this object, sectional orthographic projection. So in this object we have to draw first sectional front view, that is sectional front view looking in the direction X, then the top view and the side view. Okay, so we have to draw the sectional front view looking in the direction X. Whenever in problem or whenever in question, the sectional front view or the sectional side view, whatever the sectional word is mentioned, then you have to recognize that this problem, it is not a normal orthographic projection problem, it's a sectional ortho. Okay, so don't miss out that you have to take a section, you have to imagine the cutting plane. Okay, so here sectional front view looking in the direction X means what? This is X directions. Okay, so this A and A, so this is the cutting plane, this is our cutting plane. So you have to imagine that our imaginary cutting plane is cutting this object by this direction and by this line. Okay, so sectional orthographic projection means what? We imagine actual construction. Let's calculate the total length, height and the width. So total length is equal to so we have to draw the sectional front view looking in the direction X, means total length is equal to this is our overall length. So how to calculate it? Just from this to this center line, it is what? 70. So let's add 70 plus, here it is radius is equal to 60, diameter it is 60, so radius is equal to 30, and plus, because this 70 is starting from this, so we have to add this length. So it is 18 minus 10, it is 8, so add 8. So length is equal to 70 plus 30 plus 8, it is equal to 108. Then height is equal to, so for height, see carefully that this cylindrical part, then this rib and this rectangular part, so this all are at the one line. Okay, all are at the one level, so you have to just add this 60. So total the diameter of this cylindrical part is what? 60. So up to this it is 60, so you have to add this 60 plus this 12 and the radius of this semicircular part, that is 17. So this 12 plus 17, it is equal to, height is equal to 89. Then width is equal to, so width is equal to, you can easily see here is 18, 35 and 18. It is 18 plus 35 plus 18, it is equal to 71. So this is our overall length, height and the width. With this calculation we can easily draw the views. So during the actual construction of sectional orthographic projection on the drawing sheet, I will provide the necessary rules and the important tips that you must keep in mind while drawing the section. So let's start our actual construction. So let's start our actual construction. First of all, draw a rough box, that's the length is equal to 108 and the height is equal to 89. So you will get idea that our front view, sectional front view, will get fixed in that box. Next, starting with the cylindrical portion, so mark the center point, that our cylindrical center point, it is at, from below it is 30 and from the left side again it is 30. because the diameter of the bigger cylindrical part is 60. So mark a center point and draw two circles, that the outer circle and the inner circle. Outer circle diameter it is 60 and the inner circle it is 40. So from the front we can't see the width of that cylindrical part, so only draw the two circles, and there is a gap in between these two cylindrical portion, that the 9 mm gap. So maintain that gap, that is 4.5 mm from the both side of the center line. That gap it is up to last, and the thickness of that cylindrical portion, semicircular portion, it is 8 mm. So mark 8 mm at the both side and draw that thickness of the semicircular part. And we can't see the curve from the front, so it's converted into the horizontal line. So this portion is get complete. Next move towards the rectangular block. So in rectangular block there are the two steps. The first height it is 20, so mark 20, and the second it is 12, so draw that, and the length is equal to 18, so mark 18 mm, and one thickness is equal to 10, so mark that. All the dimensions are given in the diagram always, so you just need to carefully read the diagram, so you will get all the dimensions. There is nothing which you can't draw by the diagram. So here the thickness is 10, so mark 10 mm, and the height is equal to 20, so up to 20, and draw that one horizontal line, it is 8 mm. Okay, so here the rectangular block front view is get complete. Then next, the horizontal line it is of the rib, so draw that. Then there is one inclined line, that is the rib, which is connecting or supportive member in between the cylindrical and the rectangular block. Okay, so we are drawing a sectional orthographic projection. So in sectional orthographic projection there is a rule that we can't draw the hidden lines, because we cut that object from the cutting plane by the cutting plane, so that hidden lines are converted into the straight lines. So here are some basic 4 to 5 rules which you have to remember for sectional orthographic projection. So the first rule is to imagine the cutting plane. Means whatever the cutting plane is given, if in this object the cutting plane is what a cutting plane is given, so you have to imagine that there is one vertical cutting plane, and that cutting plane is cutting our object by this line. Okay, so always you have to imagine. If you are not able to imagine, then you can't draw sectional ortho. Okay, then the second rule is remove the front portion. Means what? Whenever you are imagining that this object is cut by this line or by this cutting plane, so remove the front portion. Don't think about front portion, because we have to draw the sectional ortho, sectional front view of this object, na? So think about the remaining part. So this is our remaining part. Okay, the next rule, that do not draw hidden lines to the sectional view. Means what? In this object we have to draw the sectional front view, then top view, side view. So in top view, side view there are hidden lines, but in sectional front view, or if there is any another object, in that you have to draw the sectional top view, then in top view there is no any hidden lines. If you have to draw the sectional side view, so that in sectional side view there is no any hidden lines. Okay, because whenever we are cutting the object in sectional ortho, basically in sectional ortho the internet details are clearly shown. Okay, so we get the internet details, so there is no any hidden lines. Okay, and the fourth rule is the 45-degree hatching lines, means the cutting plane. Whenever the cutting plane is cut, the actual material, that portion is always shown with the 45-degree hatching lines. Okay, so this is the fourth rule. And the fifth one is that do not hatch rib, because there is a reason, because the ribs are thin supportive members. So if we hatch them, they look thicker, and may it gives wrong impression to the ship. So to avoid confusion, the ribs are not hatched in a longitudinal section. So that you just have to remember that the hatching lines are not given to the ribs. Okay, and so let's continue our front view. So here I am drawing 45-degree hatching lines. Make sure to maintain at least 2 mm gap in between each line. Okay, and the hatching lines are given to the material that is actually cut by cutting planes. That you have to remember, so you will understand where you have to hatch. Okay, so the hatching requires a focus and control. So takes your time, keep your lines even, and avoid rushing. That's the main thing. So patience will make your drawing looks more professional. Okay, so here the sun is giving my drawing some natural spotlight. Okay, so here our front view, sectional front view is get complete, and mention the dimensions which are required. And complete front view. If you find this video helpful, please subscribe to my channel. So next, move towards the top view. So for top view, width is required. So mark 71 width and the length from the front sectional front view. So we will get one rough box. Draw one center line. Firstly, we will draw the cylindrical part top view. So the width is equal to 34, that the radius is given it's 17. So mark 17 to the both side of the center line and draw the rectangular portion of the cylindrical part. Then next, the thickness and the gap in between, that from the top we can't see the curves, so draw the vertical lines. Take a projection from the sectional front view, so you will get easily the dimensions. Next, move towards the rib. So the 10 mm rib is there, so draw that rib. Take 5 mm to the both side of the center line and draw the rib. Next, move towards the rectangular block. So take a projection from the front view. And draw the rectangular block. There is one hidden line. There is one step in a rectangular block, so we can't see from the top. So draw it with a, or show it with a dotted line. Next, there are the two holes in that rectangular block. So mark center line at 18 mm from the both side, from the top and the bottom. Draw center line, and the diameter of that holes are 10 mm. So mark 5 mm to the both side of the center line. and draw the hidden line. You can draw hidden lines in a top view, side view, in any view, but in sectional front view or sectional top view, sectional side view, you can't draw dotted lines or the hidden lines. Okay, then next, in the semicircular part there are the two holes, so mention that holes. Here I'm drawing the dotted line of the inner circular part, inner hole, so show it with a dotted line. Then again there are the two holes that the diameter is 12, so at the both side of the center line mark 6 mm and draw the hidden lines of that two holes. Okay, so here our top view is get complete. So mention all the dimensions which are required and complete the top view. I hope you understand the basic concept of sectional orthographic projection. So practice drawing different objects so you can score full marks in exam. That's it for the top view. Then next move towards the side view. So here left hand side view we have to draw. So draw a rough box that the total height is equal to 89 and the width is equal to 71. Take a projection from the top view and the front view. So starting with a rectangular block, so draw that front rectangle that is 12 by 71. Then next, sometimes when I take projections from the top view to the side view, my lines are not perfectly vertical at all. Even a small 1 to 2 mm difference affect the dimensions and it become difficult. So if you are good in taking projections, then take projections and draw side view. Otherwise, take dimensions directly. That is also okay. Here I draw two corner fillets that are to the rectangular block. So the radius of that corner fillets are 10 mm. By taking dimensions, draw the curves. There are two holes in a rectangular block. So while drawing the two circles, I accidentally placed that two circles in a wrong position. I realize it afterward. So please make sure that place them in a correct position according to the dimensions. Okay. Then next, draw a semicircular part that draw a center line which is at 17 mm distance. That take the projection from the front view and draw a semicircle that the radius of the semicircle it is 17 mm. I hope you can easily draw the side view by taking proper projections. This is very simple object, so just follow the steps carefully as I am drawing and keep your line straight and accurate. In exam, accuracy and neatness are very important for engineering drawing. Always read question carefully and understand which view you want to draw and what is the position of that view. Okay, and keep your sheet clean. That's very important. And manage your time properly and practice regularly. So if you done this all the things, then you will get good marks in engineering drawing. Here the semicircular part side view is get complete, and I am drawing right now the rib. So here see always my projections are little bit of, there is a difference in 1 mm or 2 mm. I take a projections of rib and there is a difference. If you are good in projection lines, then take your projections from the top view, otherwise directly take dimensions. So here I draw a rib, then next the cylindrical part lower side, it is not seen from the side view, so draw it with a hidden line. Next the next inner circle hidden line is there, so I draw it with a dotted line. Then here I realize that my position of the two circles are get wrong, and I rectify it. Here again our rib is extended up to last, so show it with a dotted line, because from the left hand side view we can't see that rib up to last. Okay, so here our side view is get complete, so give the dimensions and complete the view. Hope you understand the theory behind the sectional ortho, and if you like this kind of content related to engineering subject, subscribe my channel and share with your friends. Thank you.